What if we could solve global water scarcity? And I don't mean with a small fix. I'm talking about a revolutionary megasystem, powered by nothing more than the sun and the ocean itself. Well, today we're diving into a vision for exactly that, a planet-scale engineering project designed to get fresh water to the driest places on Earth.
Wow. I mean, that's the promise right there at the heart of this whole thing. It's an unbelievably bold statement. And you know what? It perfectly captures the ambition here. We're talking about redesigning our planet's water cycle for human abundance.
And that right there is the central challenge, isn't it? If you look at traditional desalination plants, they are just massive energy hogs. So to really truly solve the problem, you need a system that works with the laws of physics, not against them. A system that harnesses the planet's own power. So how could that possibly be done?
All right, so the journey begins at the source. The very first step is to take all that salty, unusable water from the ocean and transform it into something pure, something light, something ready for a long, long trip inland. This is the core idea, and it is such a brilliant way to think about it. Instead of fighting the water, the system just mimics and massively accelerates a natural process, evaporation. It's basically an artificial cloud factory, and its only fuel is the sun. So, how does this actually work without a giant power plant? Let me break it down. First, you have this huge field of mirrors. They're called heliostats, and they focus an incredible amount of solar energy onto one single point on a central tower. Then, a fine mist of ocean water gets sprayed right into that superheated spot, and boom, it flashes instantly into pure steam, leaving all the salt and minerals behind, which are then collected as a really valuable byproduct. The beauty of this is just how simple it is. No complex machines, just sunlight and water. Okay, so now we have these massive amounts of pure water vapor. That's great, but it's still stuck at the coast. The next huge challenge is moving this cloud hundreds of miles inland to where it's needed most, and, you guessed it, doing it without using a ton of power. And this line just illustrates the solution so perfectly. Think about it. Pumping dense, heavy liquid water is incredibly hard work. But moving a light, low-density vapor, basically a cloud, is way, way easier if you really understand aerodynamics and pressure. The answer is something called a cloud tunnel. You can think of it like a controlled, man-made river for the atmosphere. It's so clever because it uses basic physics to its advantage. Air always flows from high pressure to low pressure, right? And from hot to cold. So the tunnel is designed to create those exact conditions. It even has these sections that get narrower, using something called the Venturi effect, which naturally makes the vapor speed up, just like putting your thumb over a garden hose. It just keeps it all moving inland with very little effort. But wait a minute. Even with a super clever design, moving that much vapor still needs a serious push and pull. A passive system is good, but a supercharged passive system is way better. So where does that main driving force come from? And this, right here, is the signature innovation of the entire project. It's a silent, incredibly powerful engine that sits at the very beginning of the pipeline, and it gives the system that initial, massive push. Honestly, its design is something straight out of science fiction.
It's called the Oceanic Mega Diamond Shield. Okay, picture a colossal membrane, like a giant drum skin, made of a diamond composite material, and it's anchored deep in the ocean. Now, when it flexes by just a few millimeters, a tiny, tiny movement, its immense size displaces a huge volume of air above it. That creates this powerful, controlled pulse of pressure that shoves the cloud forward. It's all about harnessing the incredible, stable pressure of the deep ocean to make this happen with amazing efficiency.
But you're probably asking, why on earth would you build it in the deep ocean? Well, think about it. On land, a machine this powerful would just vibrate itself to pieces. But deep underwater, the ocean itself acts like a massive shock absorber, just soaking up all those vibrations. The natural pressure and buoyancy also take a lot of stress off the structure, which creates the perfect, stable home for this engine to do its work.
So to put it simply, the Diamond Shield provides the push. It's the starting gun. It's what injects all that momentum into the cloud tunnel and gets the entire atmospheric river flowing steadily inland. But that's only half of the equation. Because, for every great push, you need an equally great pull. So at the far end of the tunnel, hundreds of miles inland, there's another incredible piece of engineering working in concert, creating this constant suction that draws the cloud forward. And what's so cool is that this isn't another machine. It's a piece of architecture. Imagine a massive spire, kind of like a giant solar-powered chimney. Its dark surfaces are designed to absorb as much solar heat as possible. The sun heats the air inside, which makes it rise and creates this powerful, continuous updraft. Well, that creates a low-pressure zone at its base, which is constantly sucking the water vapor forward, pulling it right out of the cloud tunnel.
So what we have is this perfect push-pull system. You've got the diamond shield pushing the cloud from the coast, and you've got the vacuum spire pulling it from the desert. This incredible synergy gives engineers total control over the atmospheric river, making sure there's a steady, reliable flow of water vapor coming inland day in and day out.
So the cloud has finally arrived at its destination. The last challenge is to turn this river of vapor back into liquid fresh water, and then get it to all the cities and farms.
And this final stage is just beautifully simple. The warm, humid air flows into these large condensation basins, where it cools down and turns back into liquid fresh water. This water is then collected in these canals that are cleverly covered with solar panels. And this does two things at once. The shade prevents a ton of evaporation, and the panels generate clean energy to power the new communities that spring up. And to get the water where it needs to go, the system uses these ingenious, ancient technologies that have been updated for the modern world. Things like Heron's fountains and ram pumps, which use the water's own weight and momentum to pump itself uphill, all with zero external electricity. It's just pure, brilliant physics at work.
So when you put all these pieces together, what you have is so much more than just a water pipeline. You've really got an engine for transforming the planet. The impact of actually making this vision a reality would be, well, profound.
The benefits of a system like this are just holistic. It provides abundant fresh water for literally billions of people, turning deserts into lush farmland. It also helps cool the oceans by moving that heat energy up into the atmosphere. The solar canals generate clean electricity, and even the salt that's collected way back at the beginning becomes a valuable resource, sold to industry to help fund the entire project. It's a totally self-sustaining cycle of abundance.
And this isn't just a wild dream. The sources actually lay out a very pragmatic, phased timeline. You'd start with prototypes and studies, then move on to building the first hub, and eventually expand it into a full continental network. It's an epic vision, for sure, but it's a grounded one.
This, right here, is maybe the most important takeaway of all. The number of fossil fuels used to power this entire continent-spanning system is zero. It's a closed loop, powered entirely by sunlight, gravity, and the fundamental laws of physics.
Ultimately, a system like this is really a statement of intent. It suggests that maybe our biggest limitations aren't technological, but are actually a failure of imagination and will. And that leaves us with a really powerful question. Are we ready to build a world of abundance?